Hello, algebra students. Today we're going to be continuing working with parallel and perpendicular lines. So I'm going to go ahead and share my screen so that you can see today's presentation. All right, our first slide is a warm-up. So go ahead and pause the video and give it a try. All right, welcome back. So it says write each equation in slope-intercept form. Let me grab my pen here and we'll go over this. So let's look at line A first of all. So in order to write an equation in slope-intercept form, I need a slope and an intercept. So it looks like line A has a y-intercept here of 6. And it looks like it has a slope. Let's see here, to go from any point here, I'm going to fill in some dots, make it a little easier to see. Looks like it has a rise of 2 and a run of 1. So slope of 2 over 1, or just 2. So line A's equation would be y equals 2x plus 6. All right, let's look at line B. Line B has a y-intercept down here of -4. And its slope, let's fill in some dots here so we can see the slope. Looks like we're going down 1 square and over 2 squares to get to any next point. So our slope on line B looks like -1/2. So our equation for B would be y equals -1/2 x minus 4. So the question was asked, what appears to be true about the lines? Well, to me, it looks like they are meeting at a nice right angle here. So I would say that they are perpendicular. Or I would try to write that. All right, let's look at our next slide. It's some vocabulary. So again, pause the video and jot this down into your student journal. All right, so notice that in order for lines to be parallel, they need to have the same slope. In order for lines to be perpendicular, it says the product of their slopes is -1, or their slopes are opposite reciprocals of each other. All right, so please add this to your notes section on page 108. There are 2 note spaces and you're going to have 2 examples to write down. So maybe write this one in the bigger note space at the bottom of 108. And go ahead and pause the video, copy this down, and then we'll go through it. All right, the example says, which of the given lines is A, parallel to, and B, perpendicular to this line? So when you're asked this question, when you're looking at the slope, so the slope here is 2/3. So to answer part A, any line that's parallel to that line would have to have the same slope of 2/3. So I look at my examples here, my choices, 3/2, no, it would be B, right? Parallel, same slope. So my answer is B. To answer part B, this time I'm looking for the one that's perpendicular. So to be perpendicular, the slope needs to be the opposite. So since this is positive, it'd be negative. And I need the reciprocal, so I flip it upside down. So I'm looking for a -3/2. So there's my 3/2, and it should be this, -3/2. So my answer to part B, the line that's perpendicular, would be C. All right, let's continue. This is your other example you need to add to the notes section. It says tell whether the given lines are parallel, perpendicular, or neither, and justify your answers. So again, remember, in order to tell whether lines are parallel, perpendicular, or neither, I need to look at their slopes. So I can see on this second line that my slope is 1/3, but with this equation and written in this form, I can't tell what the slope is. So I'm going to rewrite this in slope-intercept form. So I'm going to move my 4x over. And then since I'm out of room, I'm going to rewrite it. So I still have my 2y on the left. And since I want it to be y equals mx plus b form, I'm going to put that -4x first. The 6 is a +6. I'm going to write it as +6 over here. I'm going to divide everything by 2 to get the y by itself. So this equation is y equals -2x plus 3. So now I can look at the slope of this line, which is -2. Since these slopes are opposite, right? One's positive and one's negative. This one's 1/2. Is this 2/1? Yes. So since the lines have slopes that are opposite reciprocals, I can say that they are perpendicular. All right, let's continue. We're going to jump to some extra practice on page 109. And the instructions for this problem say write an equation of a line that passes through the given point and is parallel to this line. So all we need from this line here is its slope. All right, so I have a slope and I have a point. So whenever you're given a point and a slope, the easiest way to write the equation is to write it in point slope form. So I'm going to use point slope form, which remember is y minus y1 equals m times x minus x1. All right, so this is my point, my x1, y1. And I'm going to put it all together and write an equation. So I have y minus y1 equals m times x minus x1. All right, I'm just going to clean this up a little bit. Minus and negative is the same as adding. All right, so this is point slope form. Note, you don't need to change it to slope intercept. This is a totally valid, correct way to write the equation of a line. So that's what it looks like. It has the same slope as this given line, but it passes through a different point. All right, we're going to try the same thing on extra practice problem number 8 on 109. So again, this is our x1 and our y1. I want the lines to be parallel, so I'm going to use a slope of -2 and write my equation. So again, y minus y1, if this is already negative, when I do minus a negative, I'm going to get a positive. I put my slope in front of the parentheses and subtract my x1 from x. So y minus y1 equals m times x minus x1. All right, in the next group of practice problems, I have to write the equation of a line that's perpendicular to the given line and passes through the point. So this time I'm going to look at my slope. So if my slope here is 2/3, then the slope of any line perpendicular to it is going to be the opposite reciprocal. So I change the sign and flip the fraction. So I'm going to use this slope and this point. And again, I'm going to write the equation in point slope form. So y minus y1 equals m, and notice I'm using this m because I want it to be perpendicular to that given line. And x minus x1 minus a negative, again, is a positive. All right, I think we have one more like this. Yep, this is number 16, extra practice. So this time I can almost write it. I first have to get y by itself though, so I can recognize what my slope needs to be. So this equation becomes y equals 4 divided by 2 is 2. And I'm just going to leave this as a -3/2 because it doesn't matter. I don't need this part of the problem. I just need the slope. So if the given line slope is 2, the slope of any line perpendicular to it is going to be negative. And if this is 2, that's like 2/1. So perpendicular would be -1/2. So I'm going to use this slope. And here's my x1, y1. So my equation is y minus y1 equals m times x minus x1. And again, you should get good at using point slope form. Write it down somewhere, memorize it. All right, it's a really handy way to write equations. All right, I think that's it. So this is your assignment. It's on 2 different pages today. I'd like you to try this practice quiz. You have a quiz coming up in class on Friday. The links to these problems and pages in your book is on Schoology. And again, you have a quiz coming up on Friday. All right, good luck.